Hey stats class, so I want to show you how we can modify one of the sheets, like the sheet we just did, to do a confidence interval if we're given data rather than a statistical summary. So on the last problem, we had a statistical summary, meaning they gave us the sample mean, the sample standard deviation to come up with the confidence interval. Well, in this one, we're being asked to do the same thing, but with the actual data set. So let me click similar question to get some new numbers. So it starts off wanting to know the point estimate for the mean. Well, that's just the sample mean. So what I'm going to do is I'm going to click this, tell it to copy to the clipboard, and I'm going to paste this into a spreadsheet. So I've got my problem that I did from a previous video just now with all these calculations. These were given to us. Now I'm just going to dump the data in there. And instead of this being just a number I plug in, I'm going to type in equals average, and I'm just going to click the column where I pasted my data. Same thing here, equals standard deviation, and click the column where I pasted my data. Right? For n, the sample size, you can do equals count, and click where you pasted your data. And it'll tell you how many numbers you're in there, decimal places for the sample size. And then the confidence level hasn't been determined yet, but we'll get in just a second. This is the first thing that I need, though, is this sample mean, this number right here. So round to 2 decimal places. So if you want the calculator, the spreadsheet to round for you, just use that decreased decimal place option. So 5.03 is our point estimate. Again, point estimate is just sample mean in this case. And we want a 95% confidence interval. So I'm going to make this 0.95, decrease those decimal places. I don't need to, but I'm just going to. So there's a 95% confidence interval, so you can see what we did in the previous video. If you want to go back and look at that video, you can. But all I'm doing here is this critical t value, the 95% confidence interval, creates alpha from subtracting this from 1. So 1 minus 0.95 is 0.05, but I need alpha divided by 2. I need half of alpha. So that's where this comes from. It's 1 minus the confidence level divided by 2. And then the critical t is just t inverse, 1 minus alpha over 2. And then our sample size, our sample size is not 1003, so it is n minus 1. So 12 minus 1. So I'm going to click on the cell where n is minus 1. So your degrees of freedom, which is this number right here, is always 1 less than your sample size. So I clicked on 12 and subtracted 1. You could also just type 11 in there. So there's my critical t. My lower number is the sample mean minus the critical t times the standard deviation divided by the square root of my sample size. All right, and this is part of the formula sheet that you'll be given, so you'll have access to this formula to get that lower number and upper number. The upper number is the same thing, it's just we put a plus in there instead of a minus. So when I go down to the upper number, just notice it's the sample mean plus the critical t times the standard deviation divided by the square root of the samples. All right, it's not a probability. It's not if repeated samples are taken. It is a confidence interval. So there's 95% confidence. The population mean that I'm looking for falls in this interval between these two numbers. That's always what these are going to interpret to, so you need to look for that keyword of confidence in there. All right, now they're going to make us do this again. It's changing it to 99% now. So all I have to do is go back and change this, because everything else is dynamic. I built this sheet by clicking. So now this is just 0.99. Everything changed as I did that. Okay, just so you can see, Control Z was 0.95. This was 0.25, 2.2. And now after I change it, you can see all the numbers are changing. So again, it's 99% confidence. The true mean is in between 4.68 and 5.38. All right, that's how we interpret a confidence interval every time. All right, what happens when I changed it? So look at what happened. I went from 95, 4.78, 5.28. Now my lower number is further down. My upper number is further up. So going from 95 to 99, the confidence interval increased. So did the width of the interval. This makes sense because that margin of error, that critical number times the standard deviation divided by the square root of sample size, all that stuff got bigger because this critical number gets bigger. So that margin of error also increases when the confidence level increases. So that's that's how a spreadsheet can help you do these problems. But you do need to know that calculation of how to get this upper number and how to get that critical T.